All right, so this is the last video in this series. And what we're going to do, we're going to start off by, I'm going to give you another calculus relationship. All right, so we know with acceleration that acceleration is a dv dt. Okay. But there's this trick with fractions, you know, where you like multiply by 1. For example, let me do something silly here. If I said 4 and 6, we could say that that was 4/5 times 5/6, right? Now that would be, I don't know why you'd want to do that. There's algebraic reasons you might want to introduce that, you know, for whatever reason. But the 5 and the 5 cancel each other out. So okay, fine. Okay, we just expanded and threw a 1 in there. Now, what we're going to do here now is a very similar trick to that. Okay, so what we're going to do is we're going to go dv ds ds dt. Okay, so it's just like I did with the 5 there, except I made it a ds. Okay, now this is called the chain rule in calculus. It doesn't really work the same way as fractions, but it's close enough. It looks pretty similar. All right. Anyway, so we're going to apply the chain rule here, and then you see ds dt. This term is actually a velocity term. So we're going to add to our arsenal, our calculus arsenal, this relationship here. All right. Now this is useful if we have acceleration given to us as a function of position. And sure enough, look at number 8. A particle travels along a straight line with a velocity of v, such and such, but s is in meters. So the velocity is a function of position. Determine the acceleration of the particle at s equals 15. Okay, now, our gut reaction would have been, okay, I got a v, I just need to take a dv dt, and I got my acceleration. But there's no t in there. Okay, so that's going to dead end on you. All right, that's going nowhere. Okay, so here's how we do it now. Okay, so I know that A is my V dV ds. Okay, so I could just copy in my equation for my velocity, which is 20 minus 0.05 s squared. And then we need the derivative of that. Okay, we're going to plug that in here. Okay, so we got the derivative of the 20 is 0. So here we got minus. It's going to go 0.1 s. All right, so now my function for my acceleration is minus 2s plus 0.005 s cubed. Okay. There we go. So now I've got that relationship. So all I need to do now is then plug in for s, and I'll get my number there. And I'm starting to get tired, so I'm just going to let you do that. Boom. Just plug that in there. You'll be good to go. Let's talk about number 6. Okay, number 6. A particle travels along a straight line with an acceleration a. Okay. Okay, note again there, this a is a function of position. Okay, not time. It's position. All right. Determine the velocity of the particle when s equals 10 if v equals, you see it? Do you see it? It's one of those condition things. They're giving us some conditions. All right. Here it is right there. There's our conditions. So that means we need to expect that we're probably going to have to do some integration here. Okay. So let's do this. Okay. All right. So if A is V dV ds, then we can rearrange that using integration by parts to get A ds is V dV. And then we integrate both sides. Okay, so if we have a as a function of s, which we do, we can stick that right in there. Okay. All right. So I've got 10 minus 0.2 s ds. Okay. Did you see what I did there? That's my acceleration right here. Okay. And that's going to be, oop, I didn't want that color, VDV. Okay. All right. Now we have to decide, are we going to go plus C route? Okay. We've seen that before. Or are we going to go just like plug in and see what happens? Now, the way we figure out, is it better to go plus C or is it better to plug in my endpoints, is to check how my endpoints are given to me. How are the boundary conditions? How are the initial conditions? How are the endpoints? Oh, that's the same way to say the same thing. How is it given to me? And it's given to me as at s equals 0, v is 5. Okay, that we can work with. Okay, so that's telling us we're going to have 0 here and a 5 over here on this side. Okay, and so we're going to go from position 0 up to some generic position s, so we can build a function. All right, and then we're going to go from 5 to some other speed v, and we'll leave it arbitrary, so again we can have a function. Now in the end we're going to have an equation that relates s and v. Okay, so let's work that out. Here we're going to have 10s minus 0.1 s squared evaluated from 0 to s. And then we're going to have 1/2 v squared from 5 to v. Okay. Now if we plug in our endpoints, we get 10s minus 0.1 s squared. The 0 just goes away on us. And here we have 1/2 v squared minus 25. Just like that. Okay. So now I got a relationship between v and my s. Okay. And so we can do what it asks us to do at this point, because it says what's going on at 10. Okay. So what's the velocity at 10? All right. And so now I've got an equation that will allow me to do that. Okay. And you guys are competent. I don't need to hold your hand going through that. All right. Just go ahead and you can work all that out. Okay. All right. There we go. That's the end of the first series of the new year. Okay.